Hello there and welcome to a brand new lesson. This is Hub Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at modeling with linear equations. By the end of this lesson, you should be able to translate word problems into linear equations using defined variables. You should be able to identify key phrases that signal mathematical operations in word problems. You should be able to set up and solve single variable linear equation models. You should be able to set up and solve two variable simultaneous equation models, and finally interpret the solution in the context of the original real-life problem. These are some vocabularies we'll be using along the way, and I would advise that you pause at this moment and quickly glance through. Without much ado, let's quickly look into our lesson. So since we are talking about mathematical models, let's start by defining what it is. When we talk of a mathematical model, you don't think of anything strange. It's simply a mathematical equation or system that represents a real-world situation. So any equation at all, you can relate it to a real-world problem or situation. We call it a model. So for instance, if you want the cost of a particular number of quantity of objects, goods, or what have you, if you write that as an equation, as you have here, cost equals 5n plus 20. This models the cost in terms of the quantity n. This here becomes a mathematical models. Now it is important to note that there are key phrases you need to understand before you can model out mathematically. Some of these key phrases are what we'll be considering next. So talking of these key phrases, we have them displayed here. The first one being more than. So anytime you hear more than or increased by or some, then we are simply talking of addition. You see, all of these we have over here is simply talking of what? Addition. If you hear more, so 2 more than 3 simply means 2 plus 3. 2 increased by x simply means 2 plus x. The sum of 2 and 3 becomes what? 2 plus what? 3. As simple as that. Then secondly, we have less than, decreased by, and then difference. All these are used to show subtraction. So if I say x less than 2, then it simply means you are reducing x by 2. If I say the difference of 2 and 3, then it's going to be what? 3 minus 2. You see, all these are used to show subtraction. Then we look at times, product, of, and then these three with a number. That is, if I'm saying 2 times 3, then we simply mean a 2 times 3. If I want the product of 2 and 3, then it is also the product of 2 and 3. 20 of 100 becomes 20. So that is 20% of 100. It becomes 20%. Then of becomes times. Then your 100 follows. You see, that is multiplication. Whenever we are talking of ratio, the ratio of two numbers, or pair, or we are saying something is equally shared, these represent what? Division. The ratio, equal sharing, pair, they all represent what? Division. So we have other expressions as well that we use for equal, you see. So that is S. So anytime you see S, then the preceding one is trying to tell you it is equal, you see, and then the word equal itself can also be used. Gives can also be used, and then result in. These are all expressions we use to denote what? The equal sign. Now, there are more we use also in the multiplication and division. So for specific multiplication, that is multiplication by 2, we use twice. So twice of x is simply what? A 2x. Then a double is also twice. So a double of x is also going to be what? A 2x. Then a triple is going to be what? 3 times of the variable in question. So triple is also going to be what? 3x. So now that we know these things, what are the processes we need to what? Model out expressions or phrases. So to be able to model correctly, here are 5 processes you should follow. First of all, you need to read. So you need to understand fully what the problem is all about. Identify what is known and what needs to be found. You see, if you're able to identify what is known and what needs to be found, then you define what needs to be found with variables. That is the unknown. So we say we assign variables to the unknowns. Now, in using variables, you have to be specific. And you don't use every letter at all in there that you know of can be used for variables, but you need to take note of the ones you use. For instance, if you are using the letter O as a variable, you might think it is even 0. If you use the letter S as a variable, it will get to a time you might even think you are writing a 5. If you are using L as a variable, you might confuse yourself and gradually think you are writing 1. So in as much as you are at liberty to use any letter as a variable, you need to be cautious when using any. That is why mathematics around the world usually use the X and the Y. These cannot be confused with any other numbers. Writing the X, you can just simply do this rather than this. Because if you write it this way, you might think it is multiplication. So we don't do that. Then after writing or assigning your variable to the unknown, you translate. Translation here, we simply mean you convert each sentence into what? Mathematical equations. Because it's only through that we can now solve. So we solve and then make interpretations. These are the steps we need to know when modeling. With all these said, let's quickly solve some questions so that we enhance our understanding. So let's go to our very first question here. And as you know, my first questions are very, very simple. So from simple ones, then we keep building to more advanced ones to enhance understanding. It says a number is increased by 15 and the result is 42. We are then to find the number. A number is increased by 15, the results being 42, and then we have to find the number. So how do we go about this? As our steps have said, we need to do what? Read and understand. We have read and understand. Now we define our variables. Be specific on the variables you want to use and what each variable represents. So we start by saying, let your variable, this time around we'll be using an x. So let's let x be the number. So if x is the number, then it simply implies that our model, they said the number is increased by 5. So x is increased by what? By 15 and not 5, so 15. And the results, so equals 42. Do you see? So this is what we have. Now that we've been able to define and translate, we can now solve. So x plus 15 equals 42. It simply means that x is equal to 42 minus 15. So 42 minus 15 then gives us a what? 27. So the x then gives us what? A 27. And that is all. So we conclude by saying, therefore, the number is 27. That is our solution. You see how modeling is very easy. Very, very easy. Let's solve some few more examples. Our second question here says, the sum of 3 consecutive integers is 72. You have to find the integers. Now, if we talk of consecutive, then it simply means they are one apart. They are one apart. So, for instance, if you are talking of consecutive integers and we want to start from 1, Then the consecutive integers will be what? 2, 3, and then 4. And then it goes on and on and on. You can even start from the negative. So for 3 consecutive integers, you can have 2, then you can also have a 1, and then you can also have 3. If you want 3 consecutive odd numbers, so the odd numbers, we have what? If you want to start from 3, we have 3, then 5, then 7. So they are 1 apart. Not as in the difference between them is 1. But then if we are listing the odd numbers, this comes after this comes after this in that order. If I want consecutive prime numbers, then I can start from a 2, then what comes next? A 3, then what comes next? A 5, then it goes on and on and on. So if you are talking of a set of numbers, the ones that come after the other are what we call the consecutive ones. So when we talk of consecutive integers, there is a general way we represent them when solving them under models. We know that if one or the first consecutive integer is a variable, let's say n, then the next one, we know for the integers, they differ by just 1. For instance, if you have 2 as your first integer, the next one would either be what? 3 or 1. If you are moving forward, then the next one is 3. So how do we get a 3? You just add 1 to the previous one. And if you want the next one, is going to be what? N plus what? 2. In that order. It simply means if we get our first integer, we can just keep adding the counting numbers to it, and then we'll get the next one. Apart from this way, there's also another one that says, if I have this integer, then the one in front of it is just going to be n plus 1. Then the one behind it is also going to be n minus 1. Any of these work. So then, let's come to our question. It says the sum of 3, find the sum of 3 consecutive integers is 72, and then we have to find the integers. So the first thing we do is to let one of the integer be any variable at all. So let the integers be n. So if one of the integers is n, then the other is going to be what? N plus 1, and then the other is going to be n plus 2. So that if the first integer is 1, then 1 plus 1 gives us what? 2, and 1 plus 2 gives us what? 3. So that if the first integer is 5, then 5 plus 1 gives us 6, then 5 plus 2 gives us 7. That is the whole idea behind this. So with that said, we are saying their sum is what? 72. So if their sum is 72, it simply means if we add n to n plus 1, and then also to n plus 2, we are going to get a 72. So simplifying, we have n plus 1. You know, there is just 1 in front of the brackets. So it is just going to open as simple as you see. So we have n plus n, which will then give us a 3n. So we have 3n, then plus for the numbers, we have 3 being equal to 72. Making our n the subject, we have 3n, which is equal to 72 minus 3. So our 3n is then equal to a 69. 3 times what gives us a 69? That means our n is equal to a 23. You see, so if you want the 3 consecutive integers, if n is 23, then it simply implies that our n plus 1 is equal to what? 24. And then our n plus 2 is also equal to what? 25. So if you have to check, you realize that 23 plus 24 plus 25 would give us what? 72. You see? So we can conclude by saying, therefore, the 3 consecutive integers are 23, 24, and 25. As simple as that. Isn't modeling very easy? Okay, so let's look at our third question. This would be in a form of a story. This question says, Amma is 4 years older than Kwame. In 6 years, the sum of their ages will be what? 50. Find their current age. In 6 years, the sum of their ages is going to be 50, and you have to find their current age. So we have to define our variable. So first of all, I'm going to let Kwame's age be a k. So let Kwame's age be equal to a k. Now we are being told that Amma is 4 years older than Kwame. If you are letting Kwame be k, then it will imply that Amma's age is going to be a k plus 4, because Amma is 4 years older. You see? Now in 6 years' time, then what is going to happen? Kwame's age is going to increase by 6. You see? So for Kwame, his new age is going to be k plus 6. Then for Amma, on the other hand, her new age is going to be what? Her current age, where it's k plus 4, then plus 6. Now we are being told that the sum of their ages is going to be 50. The sum of their ages, that is on this 6 years later, is going to be 50. So that is to say, Kwame's age, which is k plus 6, then plus Amma's age. So for Amma's age, if you have to simplify, you're going to get a k plus 10. So Kwame's age plus Amma's age, which is k plus 10, is giving us a 50. So we now need to solve for our k. So k plus 6 plus k plus 10 gives us a 50. We have k plus k, which gives us a 2k. Then 6 plus 10 gives us a 16. And it is equal to what? A 50. Making our k the subject, we have 2k, which is equal to a 50 minus 16. So we have 2k, which is then equal to what? A 34. Dividing both sides by 2, we have our k then being equal to what? A 17. Remember, if we come back here, we said let Kwame's age be k. After this procedure, we have realized that Kwame's age is actually what? 17. And that will mean Amma's age, which is k plus 4, is then going to be 17 plus 4. 17 plus 4 gives us what? A 21. Now let's check if the sum of their ages in 6 years' time is actually 50. So for k plus 6 then gives us what? A 23. And for Amma's age, that is going to be a k plus 10, which is 27. If we add 23 to 27, we get our 50, which makes our solution true. So we say, therefore, Kwame is 17 and Amma is 21 years old. Very simple, isn't it? Let's look at our last but one question. This question says, a shop sells pen at 3 cedis each and notebook at 7 cedis each. Kofi buys a total of 20 items and spends 96 cedis. How many of each did he buy? How many of each did he buy? So how do we go about this? we need to define our variables. So since there are pens and notebook, I'm going to say let's let P be what? Pens. So anytime we see P, we are talking of pens. And then let's let our N be notebooks. So that anytime we see N as well, we mean what? Notebooks. Now we are told that Kofi buys 20 items in total. So it simply means if we add the number of pens plus the number of notebooks, we are going to get what? A 20. Easy. We are letting P be the number of pens and then N be the number of notebooks. Their total sum gives us 20. This can be our first equation. Now, if we look at the second condition, it says he spends 96 cedis. So, spending 96 cedis for a total of N pens and then P pens and then N notebook, it simply means that we would have to consider how much a pen costs and then how much a notebook costs. You see? So we know each notebook costs what? We know each pen costs 3 cedis. So if you want the total amount he spent on the pen, then it's going to be 3 cedis times how many pen he bought. Plus, if you want the total amount he spent on notebook, we know the price of a notebook is 7. So 7 times the number of notebook he bought. We are being told that he spent a total of 96. This is going to be our equation 2. So let me quickly go over once again. It says a shop sells what? 3 cedis each. A shop sells a pen at 3 cedis each, and then a notebook at 7 cedis each. Kofi buys a total of 20 items, and then he ends up spending what? 96 cedis. And we are saying that let's let our P be what? Pen, and then our N also be notebook. So with respect to that, then the number of pens in total and then the number of notebook in total gives us 20 because we're told he bought 20 items. Then with regards to their prices, we know that each pen is what? 3 cedis. So the total cost of pen is going to be 3 times the number of pen. And we know each notebook is also 7 cedis. So the total cost of notebook is going to be the number of notebook, which we have said to be what? N. Then times the cost of each notebook. So with that, we have 2 equations we want to solve simultaneously. We can either use substitution or elimination, but this is it is simple if we use substitution. So we can say that from equation 1, that is from this first equation, making P the subject, we would have P being equal to what? 20 minus N. That is, if N goes to the right hand side, we have P alone here, which becomes 20 minus N. So with P from equation 1, let's put P into equation 2. So you say put P we've gotten into equation 2. And that is going to give us 3. Then instead of P, which is this we have over here, we are going to put this whole thing, which is 20 minus N. Then plus 7N equals what? 96. So let's open our brackets. 3 times 20 gives us what? A 60. And 3 times negative N gives us a negative 3N. Then plus 7N is equal to 96. If you want to simplify further, we have 60, then negative 3N plus 7n will give us a positive 4n, and that equals 96. So making our n the subject, we first of all make 4n the subject. So 4n equals 96 minus 60. That is 4n here, then 60 goes to the other side, which then gives us a 4n, which is equal to what? A 36. So we divide both sides by 4. And this 4 cancels out this 4, and we have our n, which is then equal to a 9. With our 9, we then substitute it into any of these equations. One is more favorable. So let's put n into equation 1. Into equation 1, we know we have p plus n equals 20. So instead of the n now, we are going to write p plus 9 equals 20. Now p is then equal to a 20 minus 9. 20 minus 9 gives us 11. And that is all. That is all for this solution. So we have gotten the number of pens bought, and then the number of notebooks bought. Hence, we can conclude. So we can conclude by saying, therefore, Kofi bought 11 pens and 9 notebooks. You can check by doing your necessary substitutions. We have 3 into bracket. We said the p is now 11. So 11, then plus 7 into bracket our n, which is now 9. 3 times 11 gives us a 33. Then the 7 times 9 also gives us a 63. If you add these together, you are going to get what? A 96, which confirms what we have done over here. Very, very simple. We are almost getting to the end of this lesson. Let's solve our last question. For this last question, I advise you pause the video and try it on your own before you come and then look at the suggested solution. So our last question says, a business has fixed cost of 500 cedis per month and produces items at 8 cedis each. It sells each item for 13 cedis. We are first of all to write the costs and revenue functions. Secondly, we have to find the break-even point. Then how many items must be sold for a profit of 250 cedis? Now this is more business oriented, and when we began, I wrote out some terms you needed to consider. One being break-even. So when we simply say break-even, then in terms of business, it is when the cost equals the revenue. That is the point at which a business neither gains a profit nor loses. You see. So with that, let's quickly answer the questions we have here. The business has a fixed cost of 500 per month. Now, it produces items at 8 cedis each and sells each item at 13. This 500 per month simply means that whether they operate or not, they are going to pay 500 per month. That could be electricity or property rate or any other thing that goes whether they operate or not. That is the fixed cost. Maybe transport might also be within that range. So for the cost function, then we are going to say the cost with respect to what? The n is going to be what? 500 cedis, which always goes per month. So 500, then plus. It also tells us that there is 8 cedis being paid per item produced. So for one item produced, it costs 8 cedis. For 2 items, it costs what? 8 times 2. Hence, for n items, it is going to cost 8n. So this is the overall cost each and every month. Now we come to the revenue. So for the revenue only depends on one stream. That is when they sell the item. And the price of each item is what? 13. So 13 N. That is all for A. So this is the cost function and this is the revenue function. Now B also says you have to find the break-even point. Find the break-even point. As I've explained, at break-even, then it simply means the cost is equal to the revenue. And that is, we have to equate these two together. It simply implies that we have 500 plus 8n being equal to the 13n. So what do? We make our n the subject. We have 500 being equal to a 13 minus 8n. You see, so 500 equals 13 minus 8 gives us a 5n. If you have to divide both sides by 5, what do we get? We get to this 5, cancelling out this 5, give us an n, and then 5 into this guy to give us 100. So it simply means n is equal to 100. So the break-even point is when they actually produce 100 items and sell 100 items. Do you see? So that is it over here. Then the last part of the question says, how many items must be sold for a profit of 250? Now, for profit to be made, then it simply means for profit, then it is the revenue minus the cost function. In other words, the revenue with respect to the number of items being sold, then the cost function with respect to the number of items being produced. That is minus. So we know our revenue function was given as what? The 13n minus the cost function, which is what? 500 plus 8n. It is important we introduce this bracket here so that it will affect the whole cost function. So that gives us a 13n minus 500 minus 8n. So simplifying further, we have our 13 minus 8, which gives us a 5n minus what? 500. So it simply means our profit function is going to be a 5n then minus 500. Now the question says, how many items must be sold so that we get a profit of 250? So for a profit of 250, then it simply means our profit function is equal to what? 250. Then we know what the profit function is. So that is to say, we have 5n being 5n minus 500 being equal to a 250. Making our n the subject, we have 250 plus 500, which then gives us a 5n being equal to a 750. What do we do now? We divide both sides by 5, and that simply means our n is equal to 150. So for the company or the business to gain a profit of 250, then they should target producing 150 items and selling 150 items. So in conclusion, we simply say the break-even of this business is what? 100 items, and then the business needs to sell 150 items to get a profit of 250. As simple as that. I do hope this lesson was useful. As usual, I'll leave you with some questions to try on your own. So here are 5 questions you can try on your own just to test your understanding. They are in the same format as those that we solved, and I do hope you'll be able to do it. Just have beyond numbers where we learn maths the easy way. If there's any issue of concern, you can also let me know at the comment section. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.